Hello everyone, this is ECE100 again. In this class, we're going to talk about some basic equipment that we use in our lab and how to use them and how to know that we're getting an accurate results from the equipment. So to do that, let's start with some safety discussion, but we're going to discuss them in the class. So I'm not going to discuss it over here. Hopefully you read the article, so you're going to go to the class and discuss them in the class. So first of all, we engineers are problem solvers, right? So how do you solve problem in a way that you are not missing out and also not cutting corners? So there are 5-step process for problem solving. So you have practiced them in your physics 160 and also in other classes in high school, hopefully. So first one, we call it givens. So every problems have some information given. So you collect them and put them under the givens. After the givens, you plan how to use these givens and how to go from point A to point B, or maybe point A to point C through point B. The plan, you basically trying to find out what equations you have to use, and is there any conversion of units you need to do, and all those things. Then after the plan, you have the equations, you have all the conversion done. Then now you can calculate. So number 3 is calculate. Number 4 is now you have answers. I want my answers boxed so I know where to look for answers. Then obviously last one would be check. You have time in your exam or quizzes, go back and check your answers. In homework, you obviously can check your answers because you have time for the homework. Those are the 5 points. So in your homework solution or in exams, I want you to follow these 5 steps. Sometimes you don't have to put them givens, plan, calculate, answer, check. But if I can see them in your work, that should be enough. We're going to solve this problem in the class. We're going to avoid that for now. So now we're going to go through some symbols that we use in our circuits. First one is your battery. Battery could be single cell, double cell, or like that. So it has 2 bar. The longer bar is positive, shorter bar is negative. And if it's a single cell battery here, if you have multiple cell, you can connect them in series like that. So negative, positive, negative, positive, right? So those are your battery symbols. Generic voltage source, if you have a not battery, just generic voltage source, you can use it like that, so positive and negative. Or if you have a AC source, you can use the AC symbols for that. There's no positive negative there, just the AC. So this one is the DC, this one is AC. And the ground point, there are 2 ground symbols we use. This one is for the earth ground, right? And another one is body ground. We sometimes use the body ground. That is basically like a broom for you. So that is like that. So this is the body ground. Is basically your car has the body ground. And this is the earth ground, right? And resistor, the symbol right there, that's the resistor symbol. Motor, that is basically a round circle with M there. And also generator has the same thing. You put a G in there for generator. Generic 2-terminal device, you have a device that only have 2 terminals. So that would be a generic 2-terminal device for you. So if you put them together in a circuit diagram, let's see, you have a battery over here or the voltage source over here. Let's say it has 10 volts here. Then you have a resistors over here. Then you have a motor over here. So that should be a simple circuit using some of the symbols we have in this slide. So multimeter. Multimeter, you have seen that in your lab. Hopefully, there are different things out there, but we use this one very commonly in our lab. It's called Fluic 117. What it can measure? It can, you can see over here, it can measure voltage, both AC and DC. So it can measure your AC voltage, DC voltage, and also you can also measure millivolts, very small voltage. Then also can measure AC current, DC current, and also it can measure the resistance and so on. So it can measure voltage, current, and resistance. Right? So now, when you measure something with a equipment, it might not be like 100% accurate, or doesn't might not have a zero error. So every equipment comes with a data sheet will tell you what the accuracy of that particular device for different range. Like if you measure 5 volts, that be one kind of accuracy. If you go measure 100 volts, that would be a different kind of accuracy for this particular multimeter. So if you look at the handout I gave you in the last class, class 1, handout for equipment component handout, page number 7, that has the data sheet for this Fluic 117. So like, look at here, we're measuring 6.333 volts. So there are different range for that. It's DC volts. So for this one, I'm gonna use the 6 volts range, because 6 volts is very close to 6.33 volts. There's a 6 volts range, 60 volts range, and 600 volts range for this multimeter. So I'm gonna obviously use a 6 volts range. For the 6 volts range, the equation I have for accuracy is here. Again, this is for you from your handout. Accuracy equation we have is 0.05% plus 2. What this means actually? He's saying that 0.05% of the reading, I'm gonna spell it out here, of the reading, which is 6.33 volts for me, plus it's called 2 counts. What is counts? Counts is the resolutions of the device for this range. So for this range, the resolution I have is 0.001 volts. So if I put it together here, so 0.05%, 0.5 over 100, right? That's a percent of the reading. So we have 6.33, right? 3 plus 2 counts. 1 counts for this range of 6 volts. If you look at the data sheet, is 0.001. 0.001. So whole things goes into volts. If I do the math over here, I should get plus minus. It's plus minus here. Let me put plus minus here. Plus minus 0.034 volts. That what does means? Let me discuss this here. So I'm measuring 6.334 volts. So my reading over here I'm measuring, that could have plus minus 0.034 volts error in there. That means it could be volts could be close to 6.3 volts, or it could be 6.367 volts. So it could go it could be in between this range. It could be 6.3 volts or 6.367 volts. That's the accuracy. So I have this much error in my reading. That's what it's saying. All right. So that's the accuracy for this 6 volts reading, 6.33 volts reading I'm getting right now. If I get to 60 volts, I would have same equation here, but I have different resolution for that, which is 0.01 volts. If I go to 600 volts range, I still have the same equation, but I have 0.1 volts resolution. So the counts will change for different voltages. We're going to do some example in the class for this. All right. So let's define those terms here. What the accuracy means. So accuracy means how close a measurement is to its true value. So this accuracy means how close a measurement to its true value. All right. And what's the precision? It's actually reproducibility of a series of measurements. So it's a reproducibility of a series of measurements. So if you take the measurement again and again, and you get the same results, that is precision. Precision does not guarantee your accuracy. You could be getting the wrong result every time, not accurate result every time, but you're precise. You're getting the same results every time. And resolution is the finest sort of fineness to which an instant can be read. So it is the fineness to which an instant can be read. That means how precisely, how closely you can read something from an instrument. Like if you have a 6.333, that means you have 3-digit resolution on that. That's what it's saying. So what comes to error here? If you're getting a measurement, let's say it's y, that could be affected by kx plus c. What is this? This is the measurement you're getting. So this is your measurement. And this is your true value. This is the offset. Your measurement, your instrument could have an offset. And this is the scaling. This is your scaling error. So what is scaling error? Is basically your scale is not accurate. So you have some scaling error there. That means you're measuring 0, but it could not be 0. It could be 0.1, or even other way around. So this is the scaling factor. And offset is that your measurement starts with a value, not starting from 0. So this measurement could be affected by scaling and offset. So let me define a few things over here. Is that let's draw a Venn diagram here. So let's see that this is the diagram here. So your accuracy is right here. So you're accurate in the here. So and also you're getting value like here. So that means this one is accurate and precise. So you're getting accurate answer plus also precise, because you're producing results again and again the same area, same values again and again. So if I do the same thing here, so you're getting the values now. You're getting the value around here, right? So it's not accurate. Accurate in the middle. Accurate is the very middle one here. So but you're getting values around it. That means you're producing same result again and again. So it's a precise, not accurate, right? It's precise but not accurate. On the other side, if you're looking here, let's say that you are doing something, your result is right here, right? So I think I made a mistake over here. Let me correct it. So this one should be is you are getting value that is random over here. So you're not producing results, same result again and again. So it's not precise, but could be accurate. This one here is precise. Look at this, precise because it's getting the same result again and again, but not accurate. This is the precise, not accurate. Right? All right. So as I said, your multimeter could measure the current and voltage. So you're measuring the voltage over here. Voltage is very simple. You just take the two leads from common to voltage over here like that. You can measure AC or DC. This is the AC over here. This is the DC over here. So it's basically measuring two end of the device. You're trying to measure voltage. That's very simple. Measurable for voltage, and your circuit is not disturbed. The other side, when you measure current, your circuit needs to be, doesn't matter AC or DC, your current measurement is a little bit tricky. You need to disturb the circuit. That means you have to break the point of interest, like you're trying to measure here. So you break there and put, so you're measuring right here, right? You need to break the circuit right there and put the meter in series. So that means your current now come here, goes through the meter, come back from the meter, and so on. So for this one, your meter in series with the circuit. So it's basically now in series with the circuit. Where the voltage measurement, your meter is a parallel to the circuit. So in the lab, we use different kind of lead. So for different measurements, let's look at the name of there. So this one is called alligator clip. And this one is called prong or grabber. Prong or grabber. This is called banana. And this was called probe. So this all has different meaning, different uses in the lab. And this one's called BNC. The full name is Bayonet Neil Conselman. There's the full name for BNC, Bayonet Neil Conselman. So these have different use for different purposes. I think that's all for today. Hopefully you have some understanding of the theory behind this lecture. We're going to do problem solving, other thing in the class.